cereal drive, Monday, Wednesday, Friday next week during office hours. So be sure that if you're interested in participating, read the information in the school wiki. It's also in Mr. Freeby's bulletin about the cereal drive. It's worth a couple points extra credit. Some of you always are looking for extra credit. Bring in that cereal. It goes right here in Indianapolis to homeless children. Okay. So we can help our little children in our community. All right, we're ready. 4.3, number 2A. Point P is on the terminal side of theta. Find the values of the 6 functions for theta. Now, you're probably looking at that problem and thinking, what in the world does that even mean? Well, it's actually quite easy. Where is the point to -2? In the 4th quadrant. So remember our butterfly bow tie we talked about yesterday. I'm going to draw the 4th quadrant piece of that. Because the point to -2 is in the 1st or the 4th quadrant. To -2. So x is 2, y is -2. Theta is always the angle of the origin. So now it's easy. Right? What do I have to do first? Find the hypotenuse. So a squared plus b squared equals c squared. Remember, when I square, everything's positive. So 8 equals c squared. What about the square root of 8? I don't recall this happening to us in our other examples. What can you tell me about the square root of 8? It breaks down. Jared, do you know how it breaks down?
4 and 2.
So 8 is 4 times 2. So the square root of 4 is 2, so that's 2 root 2. If your radical reduces, you always reduce it. Yesterday we had like root 41, that didn't break down. Square root of 8 does break down. All right, so here we go. This is going to be a little bit wacky, but don't worry, you've got this under control. Sine is opposite over hypotenuse. So -2 over 2 root 2. Now, if I were you, you don't have to do this, but if I were you, this is the order that I would simplify that in. I would go ahead and cancel these 2's. So now I have -1 over root 2. And then I can rationalize that. -1 root 2 over 2. Because of the fact that hypotenuse simplified, we have extra work we have to do as we go along. Now when I flip it to get my cosecant, I'm going to flip it right here. So -√2 over 1. Remember, you can flip it at any point, but it's going to be easiest to flip it here. All right, what about cosine? Well, unfortunately, isn't the same thing going to happen with cosine? We're going to have adjacent over hypotenuse. So again, I'm going to cancel these 2's. So I have 1 over root 2. And then I'll rationalize, so I have root 2 over 2. Thank goodness the tangent's going to be easy. What's the tangent? negative 2 over 2, which is just going to be negative 1. And then the reciprocal of that is also going to be negative 1, because it's 2 over 9. So there's a lot of arithmetic here, but the trigonometry is the same as yesterday. The problem's just worded differently. All right, let's look at the next one. Which quadrant is the next point in? 2. So I'm going to draw my second quadrant butterfly bow tie triangle. And I'm going to label the sides negative 1 and 4. Would you agree with that? Now let's do the Pythagorean theorem and get our hypotenuse. Anybody get it? What's your hypotenuse?
17.
Yeah, this one's easier. It doesn't break down. Just going to be the square root of 17. So remember, theta is here at the origin. So this is opposite, adjacent, and hypotenuse. So here we go. What's our sign?
Opposite over.
So 4 over root 17, or 4 root 17 over 17. Our cosecant then is root 17 over 4. Cosine, negative 1 over root 17. Which makes our secant negative root 17 over 1. And how about our tangent? What's our tangent?
Negative 4.
Negative 4, which means the cotangent is negative 1/4. Okay. All right. Now something different is going to happen. Where is the next point? Problem C.
On the line.
It is on an axis. It is not out here in the butterfly bow tie. If you plot the point 0, negative 2, it is right here. Now remember, any triangle you draw has to be part of the butterfly bow tie. Think about that. Can you make that point be part of the butterfly bow tie? No, no. When your angle is on the axis, then you do not draw a triangle. Instead, you must use your circular definitions. You draw a circle through that point, and you use your circular definitions. Now here's what I mean. In this problem, x is 0 and y is negative 2. You can't argue with that, that's the point. 0, negative 2. When I draw a circle through that point, what's my radius? What's the radius of that circle? 2, positive 2. Right? The radius is 2. So you have an x, a y, and an r value. Now look at your orange sheet. Certainly sine is opposite over hypotenuse, but I can't use that definition if I don't have the triangle. So what's the other definition of sine? Y over R. So y over R is negative 2 over 2 or negative 1. If you can't draw a triangle, then you draw a circle. And if you're drawing a circle, then you're using y over r, x over r, and y over x. You're using the circular definitions of the trig functions. When is it that I can't draw a triangle? There's only one time that I can't draw a triangle. If my point is on an axis, then I have to draw a circle. All right, what's cosine? X over r. Remember, 0 divided by 2 is 0. What's the tangent?
5x.
Negative 2 over 0, not good. What's something over 0? No, can't do it. Undefined. Undefined. Now, let's flip them all over. If we flip this, don't we still get negative 1, 2 over negative 2? Well, what if we flip this, guys? Undefined. And what if we flip the tangent? Now we have 0 on the top, which is 0. Now that's a little bit new. Would you try D? It is exactly the same kind of problem. Would you agree that your point is on an axis?
Yes.
Okay, so that means you're going to have to draw a circle. So my point is 3, 0. And when you draw a circle, it goes right through that point. So you should have an x value. What's your x value? 3. What's your y value?
0.
What's your r value? What's my radius? 3. Kids, if you're going through that point, doesn't your radius have to be 3? Always positive. All right, see if you can fill in your stuff using your circular definitions.
Is there a way to remember the second definition? No.
And you just gotta remember. If you think about your triangle, this is x and y. This is adjacent and opposite. This is r or hypotenuse. So if, x over r is cosine, adjacent over hypotenuse is cosine. So it kind of all ties together. Your sine, I hope you got 0 over 3, which is 0, which is going to make your cosecant undefined, because when you flip that, the 0 becomes the bottom. Cosine, did you get 1? Which means your secant is also 1. Tangent, you should have gotten 0 for the tangent, but you're going to get undefined for the cotangent. Everybody good? All right. Now, this looks like a different problem, obviously it is, but the idea is very, very simple. First thing I want you to do is remember that pi radians is how many degrees? 180. So when they tell us that we are somewhere between pi over 2 and pi, that means that we're somewhere between 90 and 180. Does that make sense to you? Okay. Now, angles are measured in standard position. And standard position means we start measuring right here. This is 0. This is 0. In trigonometry, not in navigation. Navigation with a compass, north, south, east, west, that's different. But when we're just doing straight trigonometry, this is 0, and we go this way, counterclockwise. So if this is 0, this would be 90, and this would be 180, 270, and then back around to 360. What do you think about that? Does that work for us? So that's our setup. So if I am to be between 90 and 180, then where am I? Which quadrant am I in if I'm between 90 and 180? Here? Quadrant 2? So if I were to draw my butterfly bow tie triangle in quadrant 2, because that's between 90 and 180, I have no idea what these lengths are. None. There's no clue in the problem. But I do know that if I'm in quadrant 2, won't this number be negative? And this number will be positive? And this number is always positive? The hypotenuse of the radius is always positive? So when it says, find the sine of the sine, what that means is it positive or negative? I cannot tell you what number it is. I can't say, oh, it's 1/3. I don't have any numbers. But I can tell you if it's positive or negative, because sine is opposite over hypotenuse. So sine is going to be what? Positive. What about cosine? It's going to be negative. Why is cosine negative? Because cosine is, here's your angle, cosine is adjacent over hypotenuse, so that's going to be negative. And then what about tangent? Opposite over adjacent, isn't that also going to be negative? Now, if you are paying attention to our circular x over r, y over r, and all that stuff, remember, in quadrant 2, points are negative, positive. X is negative and y is positive. So when we do cosine, we do x over r, negative. Sine is y over r, positive. So you can actually do it from the points. You don't have to draw the picture if you don't want to. Okay. What's going on with the next one? Now we're between pi and 3 pi over 2. So what does that mean? Pi to 3 pi over 2. Well, what's pi? 180. So 180 divided by 2 is 90 times 3 is 270. So remember how your labels are. This is 0, 90, 180, 270. So aren't we in quadrant 3 this time? And what do we know about the sides of the triangle in quadrant 3? We know these are both negative, and this one is, of course, positive. So tell me about the sign. Negative. Why is the sign negative? Because y is negative. Y is negative. Sign is y over r. Opposite side's negative. How about cosine? Isn't cosine also negative? Is cosine adjacent? Remember, this is your angle. Adjacent over hypotenuse? What about tangent? Positive, because it's negative over negative. Okay. Now, remember, this is our framework. Right here. This is the framework that we are using. So I want you to look at problem A, number 4. 4A, C, E, and G. We'll do the degree problems first. And let's see if we can figure out, we're not using our calculator. We're just telling whether it's positive or negative. So 152, will that be positive or negative? Let's say. C. Tangent 300, positive or negative? Cosine negative 200, positive or negative? And cotangent 500. Positive or negative. Now take a minute, we're gonna do these together, but take a minute and see if you can figure any of those out. This is your framework. You're not looking for a number, you just want to know, is it gonna be a positive number or a negative number? So think about where 152 is. Think about what sign is, and then will it be positive or negative? Right, take a minute and see if you can come up with a guess for these. This one's a little tricky because it's negative. But you'll figure it out. Which quadrant is 152 in? Quadrant 2. And in quadrant 2, this side is negative, and this side is positive, and the hypotenuse is positive. We want sine 152. The sine, here's your angle, is opposite over hypotenuse. Did you say positive? I hope you said sine 152 is positive. What about 300? Where's 300 in our setup? Quadrant 4. Guys, it's between 270 and 360. Tell me about the sides of this triangle. This is positive, this is negative, and the hypotenuse is positive always. We want tangent. Here's your angle at the origin. Tangent is opposite over adjacent. So I hope you said the tangent was negative. Now, what in the heck did you do with negative 200? You went the other way. Negative rotation is just rotation in the opposite direction. So normal, regular rotation is up and around this way. That's the way we go. But if the angle is negative, we have to go this way. Okay? Now, I need to go negative 200 degrees. Negative 200 degrees. So I start here. How far is this? 90. How far is this? 180. So wouldn't 200 be up here? So now I have, for cosine 200, negative 200, I have a triangle in quadrant 2. 90, 180, a little bit more. Positive, negative, positive. I want cosine. Did you say negative? Adjacent over hypotenuse. X over R. And then what about 500? That one's kind of an interesting one too. What about 500? You gotta go around more than once. Because if we go all the way around, it's positive. Go all the way around, that's only 360. Okay, so then this would be 90 more. So that would be 450. And we need to go a little bit more than that to get to 500. So are we again in quadrant 2 for 500 degrees? Kids, it's very logical. You don't have to know any math to figure this out. Go around till you get to 500. This is negative and positive in quadrant 2. We want cotangent. What's cotangent? Adjacent over opposite, or x over y. So that's going to be negative. Okay? Now, what about the rest of the problems? Well, what's different about them? They're in radians. So what could you do right off the bat to kind of help yourselves out? Convert them to degrees? And I'll let you use your calculator because these are going to be, some of these are not going to be very nice. So how do we change 8 pi over 9 in degrees? Well, we remember that pi is 180. So don't we just take 8 times 180 divided by 9? Or 8 times 180 divided by 9. That should be 160. And let's go ahead, let's get them all changed and then we'll go back and figure out for positive or negative. Cosecant 15 pi over 8. What's 15 pi over 8? What is it? 337.5, is that what you said? I need the cosecant. All right, and then pi over 11. What?
16.36.
By the way, I'm just marking that one positive. How's come I can mark that one positive? Yeah, anything between 0 and 90 is in quadrant 1. And what do we know about everything in quadrant 1? It's positive. There's no point in messing with those. It's 1, it's positive. And then, what's negative pi over 7? What?
Oh, negative 9.35.
180 divided by 7 is 9.
Negative 25.
Oh, I don't know.
Okay. All right, so now we've got degree measures. So now we can figure out whether we're positive or negative based on what quadrant we're in. All right, so where's 160, guys? What quadrant is 160? 2. One more time, not gonna do this every time now. You gotta know, 90, 180. 160's in between there somewhere. So this is negative, positive. We want cosine. Cosine is negative, adjacent over hypotenuse. X, cosine's x. All right, where's 337.5? It's between 270 and 360. What's cosecant? Hypotenuse over opposite. It's the reciprocal of the sine. So hypotenuse over opposite, negative again. And where's negative 25? Quadrant 4. Remember, this is 0. Negative wise, this would be negative 90. And negative 25 is in between 0 and negative 90. So I'm in quadrant 4. And I want the secant. The secant will be positive. Okay. Now we're going to add one little layer onto this. Now, instead of just deciding if it's positive or negative, we're going to come up with an answer. So let's look at this, sine 150. Now, I do circles on there. You do not need to use circles. You can if you want. You can use triangles. Because the only time I have to use circles is when the angle is on the axis. Now, is 150 on an axis? Remember, these are my labels. Where is 150? Isn't it sticking out here in quadrant 2? So you can use a triangle. That would probably be easiest. Use a triangle. This angle is 150. This is 180. This is 150. Now, tell me about that guy right there. That is the important angle. that is my theta. Can you tell me how big he has to be?
90 minus 60, 30.
This guy is 30 degrees. Now, if it's 30 degrees, guys, that means this triangle is special, right? Across from the 30 is 1. The hypotenuse is 2. And the other side's root 3. But because I'm in quadrant 2, something's negative. What's negative? The 1, the 2, or the root 3? Before I answer the question, guys, from here to here is 150. From here to here is 180. How much more do I have to go past 150 to get to 180? 30. That's where that 30 came from. Again, total logic. Nothing fancy, nothing complicated. Logic. Okay, I want sine. Sine, this is your angle now. Always, 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 the angle is the origin. So sine is opposite over hypotenuse. The sine of 150 is 1/2.
What's the unit of measurement for that?
There is none. Because you're making a ratio, and so the units are going to cancel anyway. So if that's inches or feet or miles, it makes no difference. Trigonometric ratios do not have units. They are just ratios. Okay. Wow. That is probably the single most important thing we've done so far this semester. Let's see if we can do the next one. Okay, step 1. Let's draw 240 degrees negative. So what does negative mean? Negative means you go this way. Okay, so here to here would be negative 90. And then to here would be negative 180. And to here would be negative 270, too far. So aren't I here again? This is negative 240. This was negative 180. Now, boys and girls, this is not the angle you want. This is the angle you want. So we had to go from 180 to 240. How far is that from 180 to 240? 60. That angle is 60. What's across from the 60? Root 3? Anything negative? The 1. What's tangent? Opposite over adjacent, so that'll be negative root 3 over 1. Negative root 3. Wow, this is big stuff, guys. Big, big, big stuff. All right, next. Tangent 5 pi over 4. What do you think you'll do maybe before you get started here? Figure out what that is in degrees so that you can draw it more easily. So what is 5 pi over 4? 225. So then, here we go, we're going to draw 225. Now where's 225? Well, here's 90. Here's 180. Here's 270. Whoa, whoa, too far. Isn't 225 down here in quadrant 3? Guys, 225 is between 180 and 270. So you're drawing your angle in quadrant 3. Now you gotta figure this one out. Now remember, this is 225, and this is 180. How much past 180 did I have to go to get to 225? 45. Hey, if I'm doing this without a calculator, what does that angle always have to be? 45 or 30 or 60, right? If you get 17, stop, because you're probably wrong. If you're doing this without a calculator. All right, what are the sides? That's a 45, 45, 90 triangle. So the sides are 1, 1, root 2. Anything negative?
Negative ones.
Both of the ones are negative. Kids, you're sitting in quadrant 3. Negative, negative. What's the tangent? Tangent is opposite over adjacent, so the tangent is 1. Negative over negative. All right. Let's get this section done. Cosecant, 3 pi over 4. Who's got 3 pi over 4 figured out? 135. Which quadrant is 135? 2. It's between 90 and 180. This is the angle that you want, boys and girls. Always the one in the triangle. So how far is it from 135 to 150? What's that gap right there? 45. So 1, 1, root 2. Anything negative this time?
To the bottom.
Just that guy. Cosecant. Hypotenuse over opposite. So the answer to the question is just root 2. There are a lot of steps to these problems. All right, 2 more, and then I'll stop, okay? Sine 7 pi over 6. And cotan 5 pi over 6. Okay, who's got 7 pi over 6 figured out? 210. So sine 210. Which quadrant is 210? Isn't 210 between 180 and 270? What's this angle here? How far past 180 do I need to go to get to 210? 30. That's a 30. 180 plus 30 is 210. My sides are 1, root 3, and 2. Anything negative?
Root 3 and
Both of these are negative, aren't they? In quadrant 3. So what's the sign?
negative 1.
-1/2. Beautiful. Opposite over hypotenuse. Y over R. Alright, let's try that last one on your own. See how far you can get. See how far you can get with that problem. What was the first thing you did? Everybody should have this done. What was the first thing you did? Change it into 300. So everybody got 300? If you didn't, you need to lean over and ask your neighbor. You need to be able to get 300. Where did you draw 300 degrees? I hope in quadrant 4, because this is 270 and this is 360, so wouldn't 300 be in between? What? Now, this is where we make a mistake, if we're not careful. This is the angle you want. And that is the angle between 300 and 360. See my fingers? It's 300 and 360. How big is the angle between 300 and 360? 60. This angle is 60. You must identify the angle inside the triangle. And it's 60. So this is root 3 and 1 and 2. If you're not in quadrant 1, something's negative. I'm not in quadrant 1. What's negative? Root 3. Cotangent. Adjacent over opposite, negative root 3 over 3. I didn't give you too much time. Did anybody get all the way to the end of that problem? Everybody okay with that? All right, I promise I'd stop. I'll stop.